Hi, I'm Printer Fun, and in this video I will an accuracy test of the Revopoint MetroY Pro in laser mode and in auto turntable mode. I did this by scanning a calibrated micrometer. You may already know this test. I did it with the Creality Sermoon S1 and the Einstar Rockit previously. If you're interested for the video or have already seen it, I put a link in the description and you can simply skip ahead to the results if you already know the test. So let's have a look at the scan setup. I placed the micrometer on a turntable and used marker geometries around it to allow scanning of more shallow angles. And what is important, while laser scanning, the turntable was not rotated, simply to prevent wobble of the turntable. In the auto turntable mode, it looks a bit different. There I simply place the micrometer on the dual axis turntable that comes with the MetroY Pro, and just like do its thing, you can see there are markers on the turntable that were used for tracking, so I didn't use the feature tracking in auto turntable mode. What's also important, I used scan spray for the micrometer, so for both parts of the shanks, I would anvil, I guess it's called, anvil and spindle. Since they are polished to a mirror finish, scan spray had to be used, otherwise it simply would have been quite impossible. The micrometer itself is calibrated to 125.00 millimeters plus minus 0.01 millimeters, but the scan spray of course adds thickness. Per manufacturer spec, this thickness is roughly 8 to 15 micrometers. So I added like a thin layer, so I used the lower value of micrometers and simply subtracted 2 times this value since it's on both sides. Now to the scan settings. For the laser mode of the MetroY Pro, I used a 0.2 millimeter target resolution and I scanned until I reached the quality indicator. This was roughly 5,000 to 6,000 frames per scan, and I've used a meshed in default settings, and I did 6 repetitions of this scan. In the auto turntable mode, I set the software to do 1 full rotation of the turntable with 15 degrees rotation between the single scans. So this calculates to 24 scans per rotation. And later I fused and meshed at 0.2 millimeters. And I also did 6 repetitions. The scans came out quite fine, of course. You can see here the laser scan and here the auto turntable scans, all overlaid, all 6 repetitions in different colors. This is within quick surface. You also see on the scans itself that in the parts where I applied the scan spray, so here around the spindle and anvil, also the same for the auto turntable mode, the scan results are the best, so with the least noise in the scan, because I set the exposure to be fitting for the sprayed parts. For measurement of the distance, I imported the STLs, so all 6 repetitions per scan, into quick surface. Then I extracted a plane on the anvil and in the spindle of the micrometer, and created a second plane parallel to the first plane with a quick surface, so you can like constrain planes to each other. And then I measured between the edges of these, or the edge points of these planes, maybe for those a bit more quick surface savvy people of you. So at first you extract it as a base feature and you cannot measure the base features. So what you can do is simply generating or sewing the surface, and then it gets a proper plane and you can measure it. Looking at the stated accuracy of the MetroY Pro, we can see on the website that it is rated for a volumetric accuracy of 0.02 millimeters plus 0.044 millimeters per meter length of object scanned. After chatting with the support of Revopoint, I found out that this accuracy spec applies to the laser mode exclusively. Looking at the scan results, our nominal target of the micrometer is 124.984 millimeters plus minus 0.01 millimeters. In the laser mode, we get a mean reading of 124.991 millimeters with a delta mean of 0.07 millimeters, so well within the rated accuracy spec. In the auto turntable mode, we get a mean of 124.90 millimeters and a delta mean of minus 0.06 millimeters. Looking at the reading in comparison to other laser scanners, so I now split up the diagram a bit. Initially for the Sermoon 1 and the Einstar Rockit, I had all in one diagram without giving you the mean and delta mean values. So I split it up, so now we have a diagram for laser scanners, and then we have a diagram for other scanners. So this can be near infrared, this can be like some SLS or DLP projection scanners like the MAF THREE, or the full field mode or auto turntable mode of the MetroY Pro. But let's start with the laser scanning. You can see we have our target here in this dark blue of 124.984 millimeters. Then in the yellow curve, we have the Creality Sermoon 1 with a delta mean of 0.02 millimeters. So this is like the important part for the accuracy. Then we have the Einstar Rockit at 0.02 millimeters too. And we have the MetroY Pro at 0.003 millimeters. So till now, it is the best performer in this chart. Looking at the auto turntable mode in comparison, in orange we have the MAF THREE with a delta mean of minus 0.1 millimeter. And then we have the auto turntable mode of the MetroY Pro with a delta mean of 0.06 millimeter, so better than the MAF THREE. This could be so the MAF THREE has like some foam board calibration blades, and I guess the glass calibration blades of the MetroY Pro simply provide better calibration results. But we will look at in a separate video at the MAF THREE.